Okay, good afternoon. So, sorry for the delayed start. Um, I don't know how many of you were in today's EC seminar? Bunch of you. Any comments, thoughts, anyone? No one asked questions. So,
I know one thing you said about using the differential execution,
huh?
one spectrum one way or the
All
other
right.
or the other. Does that also be used for like finding purposes? Just randomizing
Indeed. I mean, in a way, some of the techniques he's talking about are also used for fault tolerance, bugs causing crash, and I think in this case is that uh, closely related. Yes, absolutely. So the whole notion of multiple versions or simultaneously active at the program level or even kind of different pieces and all is there. Um, I guess the other part which I found kind of fascinating in a way was that how sophisticated attacks are and the pain to which they go through to exploit sort of things. And so I think some of the techniques he's talking about are obviously also extract significant performance, area, power, those kind of penalties as well, and therefore some of the hardware things he was talking about are, while sort of still creeping into the big processors, are not yet present in kind of the more embedded type things, and also sort of specific to uh, what sort of we are talking about. So in many ways our embedded systems are even more unprotected than what he was talking about. I guess the other thing is the mindset, which is, I think, for the longest while, particularly in sort of engineering disciplines, we have chased performance. And I think security should be as much a consideration as you design your systems. And I would also add another one, which is sort of increasingly coming into place with a lot of things, which is ethical or bias or fairness of our systems is something that computer science has begun to worry about. But even within E, when you're kind of making decisions of various forms based upon some input, so security, when these kind of softer things which used to be softer considerations in many ways are becoming sort of paramount. So anyway, and there is, at least in security, there is a lot of economic value as well, because as the speaker put it, when the pain point increases, people will pay for it. And I think incidents like Equifax, this thing and all, I think sort of forcing common lay people to also sort of think about the consequences of our systems being not being secure. And lest you think this is just a software problem, it's as much a hardware problem. In fact, as I had started saying last time, I mean, hardware, software, they're just expressions of an algorithm, and oftentimes your expression can have problems. One example which the speaker cited at the very end was the so-called row hammer attack on memories, which basically means that by repeatedly reading location in DRAMs, you can cause bits to flip in neighboring locations, and in fact, thereby sort of leap over defenses that are normally placed in our computing systems. Okay, even at the level of operating system or hypervisor, which controls virtual machines. So your virtual machine running on Amazon, you can do stuff that causes damage to some totally different virtual machine running on the same thing. So lots of issues like that. Any other comments, thoughts? Okay. I'll be teaching a course on security aspects of IoT and embedded systems in winter under 209 AS. So those of you are interested, check it out. Okay. The other thing I wanted to do was, before starting on the formal lecture, kind of walk through the project things that I had thus far put in place, and there are a few more ideas that I have, which I wanted to also kind of go over. But let's sort of talk about those. And the way what I'll do is I'll be announcing a couple of additional office hours for this week, so that you can come and discuss topics with me, because currently I only have two 1 hour regular slots, Wednesday and Friday. But I'll schedule some for Thursday and perhaps make the one on Wednesday longer. So that's kind of the plan. Okay, so let's talk about the stuff that I had put out there. Um, virtual reality based car simulator. So this is being driven by kind of a broader motivation that broader problem that we are facing, which is as we are beginning to do research with cars and drones and things like that, it's very hard to experiment with them because I certainly can't take out these things out in in the road. So just to give you an example, one of the things that we are currently working with is, and that in itself is a possible project area, which is using sensors that you just regularly have, wristband sensors and phone sensors and all. We want to be able to make inferences about the mental slash cognitive state of individuals during their day-to-day life. Particularly things like, are they getting stressed, depressed, fatigued, those kind of things. And one of the ways it manifests itself is their driving habits. Okay, you drive aggressively if there was a bad day at work and all, and we want to be able to detect those. Now the problem is that for other things we could do human subject studies, hand out sensors, collect data, but if it is looking at distracted driving, it would be pretty problematic for us to induce these kind of things while you're driving a real car. So the thought out here is that could we create a lab scale test bed by using the kind of stuff which gaming technology has given to us, and thereby then the human subjects we're working with, we kind of call them in the lab, essentially kind of create a El Cheapo driving simulator. Now, driving simulators exist. Car companies certainly use them, but they are like millions of dollars kind of things, and even the low-end ones are hundreds of thousands of dollars. Okay. So the notion out here is that Grand Theft Auto 5 has some capabilities so that you can interact with the game engine, and then together with kind of the usual controls that games provide, sort of steering wheel, brakes, stuff like that, and a VR system or perhaps a wraparound type display, could we create a system where it gives a somewhat realistic experience, and at the same time we can do things like inject interruption, and also imagine they're going through a session and we kind of do a text message comes in, or someone calls, or just creating those kind of distractions which might cause issues, or someone cuts in front of you. So we want to create sort of a system along this line, cost being a consideration. So that's where, so certainly some of the inertial dynamics we can't create, that requires sort of having kind of a car-like unit held up in some mechanical contraption, but other aspects of a driving experience one should be able to. So that's what this project is about. We've given some, and then also Vikrant Jayakumar, my student, he's kind of the mentor. In a similar vein, I don't think I have listed that as a formal project. There's a lot of research at various universities for drones, and again with drones also we face the same problem, which is if you're working on a new control algorithm or some other new feature, you can't just go out flying them. In fact, with the kind of rules that are being put in place, it's pretty tricky to fly in most urban places. For example, DJI is the most prominent company which makes drones, and their latest firmware now, the drone, if it detects if it's in an area which violates FAA edicts, then the drone will not even take off. And the edicts are such that if you are within 5 miles of an airport, then it's considered to be area which is sensitive. How many miles do you think we are from an airport? Yeah. Huh? What if I tell you less than half a kilometer away? The Ronald Reagan helipad is classified. That's where you see those emergency helicopter bringing in. Okay, so it classifies as an airport. Your drone flying on the campus poses a threat to it, and therefore you have to, depending upon your interpretation and type of user you are, is either you have to inform them or seek their permission. And there are several others. Century City has some, another helipad, and of course, we are within 5 miles of Santa Monica, which is a commercial airport. So drones create similar problems. So again, a way out there is to create a simulation environment, and there are a variety of simulator needs. So ideally, you might be able to want, like, let's say you come up with a new control algorithm. Okay, you have an implementation on a single board computer, but now you want to test it out as if this drone was flying in some space. Okay, so conveniently, people have started looking into interfacing control software with various kind of simulated environments. So in robotics community, there is a package called ROS, Robot Operating System, which is used, and a few others. Again, using these, it would be neat to create kind of a drone simulation environment and perhaps even mate it with Google Earth or some system like that, where you have the necessary world data. So essentially, your software running on single mode computer would think as if it is controlling a real drone, and the real drone dynamics are coming from that simulation, the world simulation engine. So that's a second related project that one could pursue. Hyperspectral Imager. So for this, I've listed myself as kind of the mentor. So what this is driven by the following, that there are a variety of physical signal modalities which people have shown in recent times can be used as kind of imagers of the space around us. If you think about it, I mean, imaging is a concept which basically says, look, what is where in kind of the space around us, or inside some object and things like that. And we use a variety of different electromagnetic, EM waves, pressure waves, these kind of things. And you name it, and you probably have an imager corresponding to that. So we have sonar, ultrasound sonars, we have optical imagers, we have RF imagers. There's a lot of cool work happening where people use Wi-Fi signals and all to kind of just see what's happening and measure all kind of stuff out there. Now, each one of these signals measures a different facet of the surrounding world, if nothing else, because their wavelengths are different. So hyperspectral imaging is this concept that you simultaneously image the world in multiple modalities, which each one of which is giving you kind of a different perspective in the sense of triggering different aspects. So some things you can see at some wavelength, and other things you would see at a different wavelength, and then fuse them together. Now, the nice thing about image modality is that it comes close to being a universal sensor, in the sense that you can either have a lot of simple sensors, or you can have a few of these powerful cameras, and you can kind of peer into the world. So for example, some of the work in recent times have shown that with RF imaging, you can sense occupancy, heartbeat, location, sleep habits, all these kind of things about humans without humans wearing anything. Okay, so these are kind of nice little sort of universal sensors of ourselves and our spaces. So the goal out here is to create a hyperspectral sensor with a common processing front end. So again, in recent years, deep learning, which is neural networks, have worked tremendously successfully in recognizing things in images, particularly optical images. So the notion out here would be that we create these kind of multiple parallel imagers, which are capturing images of the same space but in different frequencies, and kind of combine them together. So you can imagine a very simple one, optical plus acoustic. Okay, and now imagine that if I'm looking at a scene, some aspect of recognizing an object may come from the shape and the color and all, but equally well it might come from what your microphone array might be picking up in terms of sound you are making and its characteristics. So by fusing these multiple images together, we can have a more accurate kind of depiction of the world. So that's the goal out here. The hardware part here is more about finding the right type of imager and kind of feeding them into a common computing platform, probably some sort of a embedded GPU, or perhaps even just a PC with a GPU accelerator, and then show kind of a multi-modality kind of thing. In some interesting example, could be something to do with occupancy or human movement or things like that. Questions on any one of these? Feel free to interrupt, otherwise it will be just a one-way presentation. F-110 scaled autonomous vehicle. So the F-110 scale part is just incidental, mostly because, so the idea out here is, again, lots of cool work happening in autonomous vehicle space, and there's a community which has developed, which even seeks to do competitive things around this. But unlike sort of NATCAR and these kind of things which some of you might have played with, these are really seeking to mimic what emerging sort of autopilots and these kind of technologies are doing. So these are small cars equipped with all sort of fancy sensors and again deep learning and GPUs and lidars and things like that. So the goal out here, so F110 I mentioned because that's the 1/10th scale cars for which a competition is run. And then the other interesting thing which happened recently is that Baidu, the Chinese company, their AI unit, which is one of the main, one of the very nice AI labs in the world, they have started in conjunction with a whole bunch of other companies an open source autonomous vehicle software toolkit called Apollo, which is on GitHub, as you can see from the URL. So my aim out here is let's create an autonomous vehicle platform which is sensor rich, and then perhaps port Apollo or some variant of it so that there is some autonomous behavior so that it can operate in some sort of a cluttered space. We can kind of mimic the kind of behavior that you might have on roadways and things like that. Now, I have in this one, I purchased pretty much most of the kit which F110 specifies for their baseline stuff. So much of the hardware is there, a couple of custom sort of plates on which to mount things and all which are missing, so they will need to be fabbed from either the machine shop or the cutter, and then kind of do some interesting sensor processing and or planning kind of work on top. So that's another one. Embed analyzer. This is really driven by this course. So right now we do this auto grader, which is kind of working fitfully right now. But if you think about it, ultimately all we do at the auto grader is that we have some sort of embedded board or boards, and they inject waveforms into your system, into the device under test, and they examine. So it's basically a test instrument. Okay. Now, historically, the problem we have always faced in such classes and such homeworks, even at undergrad level, is that essentially either students come into the lab and work with instruments, or you are beginning to see sort of these USB type analyzer and all which come, or the systems like autograders and all that we are creating. The project out here is, since Embed has all the necessary capabilities, create a unit which we can hand out to the students, and essentially through some sort of a language, and what we use in autograder is a good starting point, would feed signals into the actual device under test, which would be another embed or another board, and then capture its output. But more importantly, do it in a manner which is secure in terms of grading. Okay, so you can imagine a MOOC type class where kind of an instrument is bought, which is another embed, and a device under test, and we are able to do kind of guaranteed correct grading remotely. Adversarial audio commands. So what this is referring to is the following, that in recent times, people have shown that a lot of machine learning systems can be fooled by an adversary which feeds into it a appropriately designed input which will elicit an incorrect response. So, so machine learning systems have gotten pretty good. You hear numbers like their recognition accuracy for images and all is 99% or 95% and things like that. The problem is they also still fail. But normally when you think of them as failing, that maybe they will sort of confuse between nearby labels, nearby objects. But it turns out that the way these systems work is you can design to elicit specific failure mode. So I can have a panda be declared to be a monkey, or a panda be declared to a car, or totally sort of different things. Now, it's been shown with images. Could we do it for speech? So the idea being that could I design an audio command which, when fed to Amazon Echo, to a nearby human sounds like one word, but the recognition system in Echo recognizes it as a different word. Okay, and perhaps by doing so, you might think it's an Enclave command, but deep down I'm purchasing something from Amazon. So could we do it? So an audio clip which to humans appear one way and to the machine appears another way. And usually the trick is that you put in subtle amount of noise. So the adversarial examples for images that I'm doing. So if a panda looks like a car, to machine it looks like a car, but to human it's still like a panda, but there is deliberate noise added to it. So this one is a bit more researchy in the sense that you'll have to there's a chance of failure. Let me put it this way on this one, as is with a lot of research. Acoustic activity recognition. So the idea out here is that we are seeing now, besides Amazon Echo, there is Google Assistant, and there is Apple's Pod, which is coming out, and there are a whole bunch of other such speaker-like devices which have emerged, and they are kind of generally go under the name of artificial digital assistants or things like that. And they usually are designed for you to give some command and they respond in some way. But if you think about it, they have a whole package of sensors on them. They have a microphone. In fact, they have a very sophisticated microphone array which can give you direction of the sound. Perhaps you can even estimate um, the distance. You could control it because they are what are called as beam-forming arrays. So they can be sensitive to a particular direction. They certainly can generate sound, these devices. They have radios. So the notion out here is that what all can my Amazon Echo, just using these innocuous sensors, infer about the space that it is in? Could it figure out the size and shape of the room? Could it figure out how many individuals are there? Could it figure out that I'm watching a TV, what program I'm watching, those kind of things. So just could we make these things as kind of activity sensors in the space? So go all out, make use of this. So now, of course, Amazon Echo and Google Home are kind of closed source hardware, but there are equivalent systems that are there with off-the-shelf hardware. There are a couple of them around, one from Seed Studio, another one from a company called Matrix or something like that. So using those hardware and then again doing creative sensor processing to learn about what is happening in the space. Magnetic localization. So the idea out here is that in many applications, we wish to know where an object is. And very loosely speaking, you localize an object by either sort of tracking it when it is not cooperating with you, in the sense that either that object emits some signal of its own, or that object leaves a signature as it interacts with things. So like, for example, your eyes can see me because the light incident on me is then bouncing back and reaching your eyes, and therefore there's some sort of a passive optical sensing that you are doing. But you could also imagine that I can cooperate. Maybe I have a radio which sort of emits a thing. So there are cooperative targets and non-cooperative targets. So magnetic localization, the idea is that in many cases, the object is perhaps too tiny for us to put much active electronics on it, and at the same time it is too minuscule to do things passively. But maybe what we can do is we can make it emit a magnetic field by attaching a magnet to it. So this thing comes from people in marine sciences and all who want to track very tiny fish, and so tiny that we can't really put any meaningful electronics on it, and meanwhile they don't offer really much more of a signature. So the notion being that by attaching tiny powerful magnets to them, could we then track the resulting magnetic signature? So this is motivated by one of our collaborators, marine scientist in UK, who kind of suggested this idea. So there's a prior work actually in this course almost 10 years ago, where we had explored this magnetic technology for a different purpose. So the idea was this link that you see called Smart Table, and what the student had done was we were trying to see when little kids play with blocks, and we wanted to study together with some childhood education people as to how they were playing with these blocks, how many attempts it takes and stuff like that. Now, one way of doing it is put a camera and kind of work with that. The problem with cameras and all is, besides kind of the privacy part, some human has to sit down and analyze it. So what we were instead doing was we created these blocks which had magnetic footprints. So in the sense that every face of a cube, for example, would have a unique magnetic signature, and then the table, right under the veneer of the table, we had a dense array of magnetic sensors, and then as the children would play on it and they'll flip the blocks and move them around and all, we can basically track their actions because through that. Now, magnetic technology is something which has been improving, magnetic sensing technology is something which has been improving tremendously in recent years, in no small amount because of our smartphones, because magnetic sensing plays an important role for inertial in the IMU, so it has been a good driver and there's been a lot of improvements there. So now we can do things which we could just only dream of in terms of sensitivity and accuracy 10 years ago. So the goal accordingly is more ambitious. Could we track tiny little thing? Imagine an aquarium with tiny fish. Could we track them in that 3D space? So that's kind of the project idea out here. Let's see, what did my student put out here? Okay, so what this is about is the following, that there is a lot of concern that our systems like drones and autonomous vehicles and all are ripe targets for adversarial attacks. And even if you make the software secure, perhaps using the kind of techniques that the ECE seminar speaker described today, you have other vulnerabilities because these systems interact with the physical world through sensors and actuators. And as I had shown in kind of the first slide set, you can attack things there. You can manipulate the analog signal, you can manipulate the actuator, and thereby cause the system to behave incorrectly. So the problem, one way of thinking about this problem is that this is a problem of estimating the state of the system accurately, so that you can then control it properly. So the student of mine, Amr, he has been working on this problem of secure state estimation, and what this project is about is that could we do this problem in context of drones which are flying and which have obviously sensors and actuators and which can be attacked. And several papers in recent times have shown specific attacks on these sensors and actuators. So could we, so I think, for example, I had mentioned, I think the very first lecture, that a group in South Korea showed that they can attack the accelerometer and gyros and the drones by targeting acoustic noise at it. So in the presence of these kind of attacks, but by making use of diversity or redundancy that exists in the system, could the drone still estimate its state securely, and then we are better able to control it. So this is the goal out there. This does require kind of rather low-level software, so that's why I think he put hackers only. Okay, hacking inverted pendulum. This is a baby version of this problem. So here, instead of looking at a full-blown drone, we just want to look at the so-called inverted pendulum. So inverted pendulum refers to a pendulum which, unlike a conventional pendulum, is inverted in the sense that it has a hinge out here, and your goal is to balance it by moving the cart. So imagine a pendulum with the hinge on a cart, and you're allowed to move the cart, let's say in 1D, and as a result you balance. It's just equivalent to like taking a stick and trying to balance it on your palm by moving your palm around. If you're static, then it will fall unless somehow magically it is in that equilibrium state and it's not perturbed, but that never happens. So in this particular case, the attack would be that there is a controller which is running on your embedded system, but the embedded system has been compromised, so that controller has been compromised. So the adversary is trying to bring down your inverted pendulum or equivalently crash your drone. And what you are doing is you are trying to prevent that from happening by intercepting the command going out to the motor. So using something called hardware enclave or other security technologies, let's imagine for a moment I have a way to intervene any command an app is sending out to the actuators in a guaranteed manner. Now, question then becomes, what will we do? How will we know whether this command is safe to send out, or is it that an adversary has taken over and is trying to crash my drone or bring down the pendulum? So the goal out here is that construct good attacks and also think of defenses in this context. So if you're interested in either one of these projects, Hackers Only and Inverted Pendulum, best thing is to talk to and kind of go into details. Again, a lot of the hardware and all we already have, so some of these things are more about the software side of things and thinking about attacks properly. Sonar-based security mechanism against sound attacks. So a few slides back, I talked about adversarial audio commands, but there is a whole other range of attacking these acoustic digital assistants which have emerged, and the challenge with so the kind of attacks we are seeking out here is that someone is giving a spoofed command to my digital assistant, to my Amazon Echo, for example, and we want to detect it and prevent it. So some of the work, again, I think last time I was mentioning, some of the work has created like ultrasound-based attacks and things like that. So could we prevent these attacks? And one of the ways is to validate. Could we authenticate the source of the command? So when the receiver gets a command, could we say something about, oh, it is coming from that there is a live user there. It's not like in an empty room, and that the sound is coming from the same location where the human being is. At the same time, we don't want to burden the user. We don't want them to carry some special gizmo, press a button when giving a command. So we want to maintain the user experience. So the notion out here is that could we perhaps use other types of sensors to do this thing? So one recent work that some of my students did was they basically made use of the speaker and microphone to essentially try to infer something about is there someone in the room. So the idea is if a sound was emitted by outside the perimeter of the room, then we will not honor it. But there are other sensors, and in this one what we want to explore is that TI recently released these millimeter wave sensors. Millimeter wave is essentially terahertz type radio frequencies. This is the kind of stuff you walk through when you go through the TSA thing. Okay, those big things, you stand or whatever, raise your arm, and then they kind of scan you. Okay, so these are very high frequency, very short range, very short wavelength type radio waves, and TI recently released very simple, very low cost chips which are basically millimeter wave radars. They emit and they look them. This is the kind of stuff which is being used by cars and all also for scanning the activity on the road. So the idea out here is that use these millimeter wave sensors, which actually so happens that they just arrived today for me to play with, and take our existing open source Amazon Echo and kind of marry the two and create a millimeter wave version of authentication mechanism so that we can have a system like Amazon Echo kind of authenticate the presence of the user. Okay, any questions? Next one, virtual gyroscope. So what does gyroscopes do? Anyone? Angular velocity, yeah. So essentially the rotational part, right? Now, gyroscopes unfortunately are extremely power hungry and expensive. They're costly. So Now, if you think about it, accelerometer gives you linear acceleration, and magnetometer gives you the magnetic field, and particular your orientation relative to Earth's magnetic field, right? So from the vertical and also relative to the direction to the magnetic north. So actually, there is a redundancy out here. By using accelerometer and magnetometer, you can mimic a gyroscope. We don't do it necessarily that way because partly because of accuracy reasons, if nothing else, and also the computation is a little bit tricky. But there has been some work on emulating a gyroscope using accelerometer and magnetometer, but it's been mostly kind of, let's say, more at a theoretical level. So the idea out here is to A, implement it, and B, then use this thing to duty cycle the real gyroscope. So kind of the idea is that we'll keep magnetometer and accelerometer, which are lower power, on all the time, and we're going to be computing the mimicking the gyroscope, and then when it's warranted, we are going to turn on the real gyroscope to get a more accurate reading. So kind of essentially use a computed estimate and then use that estimate to drive the costlier in terms of power gyroscope sensor. So the algorithms and all are available in few papers. I think it's a group out of France. So the first task would be to realize them and see how well they work relative to the real gyroscope, and then kind of implement this duty cycling scheme. Time attack prevention on IoTs. So this came out of some discussion we have been having in my group, which is that one of the ways you can mess with a lot of systems is by fooling them about the notion of time. And if you think about it, lots of IoT systems, lots of cyber physical systems do realize on having a good notion of time. In some cases, a good notion of rate, like for example, sampling rate. Sampling rate is used by the control system or by your sensing, and it's an implied variable, and if actual value is different than what the system think it is, then you may reach wrong estimates. Like for example, you may compute the velocity of the target incorrectly and thereby mistake where the location is going to be, those kind of things. But there are other examples also, like for example, maybe my home security system is set to open the door at a particular point in time and all, and if I mess with the system's notion of absolute time, it will take those time actions at incorrect time. I could also do other things like, I don't know, a lot of us like maybe you have set your power hungry system, like let's say car charging to a time when the electric rates are low, but I want to mess with you, so I'll make it happen at the wrong time and thereby cause economic damage. So there are a bunch of examples like these. Now, the problem is the following, that when an application gets a notion of time, um, how does it get it? Like let's say you're writing an application in Linux, how does your application know what time it is? What do you do? I'm asking even simpler, like what function calls you would, what kind of calls, is it that you go directly to a timer and read it, or like how do you get the notion of time? Like how do you know what time it currently is? And who provides the answer to that function? Huh? Okay, so I think part of the answer you're giving, part of the answer you're giving, but neither one of them still are. So you're saying there's some hardware. So obviously, I would need some sort of a timer, some sort of a counter to maintain time. And what you're saying is that I need to set that timer, and I do that by going to a server on the network which tells me what time it is. Okay, but still, when an application reads it, who does it go to? Like What's the application?
The operating system.
Operating system, right? I mean, it's the operating system which is sitting in between you, your application, and all the hardware resources, right? The problem is that OS can be compromised, right? Rootkits. Anyone heard of rootkits? Huh? Not yet. Okay. So the idea behind rootkit is that I'll replace kind of layers that you will think you're running on the real OS, but actually the adversary is sitting, has compromised it, and you are it's basically sitting above the real OS in between. Okay, so it's basically a systematic compromise of your operating system itself. Okay, you just cannot trust anything at that point. So what has so these threats have emerged where the OS itself can be compromised. So who can you trust? So again, at the very end, today's speaker had mentioned this thing called hardware enclaves. So hardware enclave is a technology which Intel and ARM, they have begun to provide, and kind of the idea is that there is a part of the processor which is where everything where inside which things which are running are encrypted, and the only entity which needs to be trusted is Intel, or the manufacturer of the processor, and not the operating system. So the idea is that I can compute stuff inside the enclave which even the OS cannot have access to. Okay, by making use of memory encryption and a bunch of other stuff, together with together with um, together with uh, some sort of a certificate mechanism which gives you access to, which lets you sort of trust Intel eventually. The problem is that these enclaves are still susceptible to various kind of attacks, and one of the ways they're susceptible to attack still is the notion of time. So since we're talking about NTP as the way to get access to network time, so your network packets are still coming through the operating system. Now, I can encrypt those packets, so the OS cannot mess with them. They could be digitally signed and encrypted, but the OS can delay them. And the way synchronization works is by measuring delay. So since the operating system or any other adversary can still mess with physical properties of the packet, they can still mess with the notion of time which the application has inside the enclave. So the goal out here is that could we design a system where we can provide reliable timing to applications running inside the enclave, so that things like control software and all on drones or other time-dependent software in an IoT can still be protected. So that's kind of a long story out here, but essentially kind of providing some mechanism out there. This again is a bit of a game where as vulnerabilities are being realized, hardware processors will probably fix them in years to come, but there is sort of a more immediate problem that does exist. Let's see. This one is dealing with the issue that oftentimes we need to process sensor data or run control algorithms and all on a platform which is not under your control. Namely, it could be a server in the cloud, it could be your home gateway or things like that, just because the resources are there. Or it could be an intermediate node on the network. So the goal out here is that could I run computation in a manner which is trustworthy on these platforms which are not under my control. And by trustworthy, I mean that the various ways you can imagine, but one notion is that they will not leak information. They are not going to compromise my privacy. So several different ways which have emerged, but one of them indeed is this hardware enclave that I was describing. There are ways to organize things so that I can run stuff on, let's say, Amazon servers, but Amazon can arbitrarily hack into OS and all and still not have access to the private data. So there's some interesting work which has been happening in this space. It's particularly important for things like medical data and all, which you do need to process in the cloud. So the notion out here is, could we do it for distributed applications where bunch of different parties collectively need to do some computation, as opposed to kind of a single client server kind of a scenario which currently people have done. Okay, so this project by a different student, Fatma Anwar, deals with the following issue, that currently when in networks, when you send a packet and the network is like a black box, and then eventually you receive the packet. And by looking at timing characteristics, like how much time it took through the network and all, you can try to make some inferences about what's happening in the network. The problem is you don't get a very detailed insight. When it comes time for, so it may be there was one particular router along the way which was a culprit. Maybe that's where there was cross traffic, or maybe there was loss, queuing, delay, and things like that. And this problem, so one of the ways we could potentially cope with this thing is if the network's internal behavior was opened up to us. And what I mean by that is, imagine if when the net packet arrives to the other end of my application, it carried information about where it was at different points in time, right? How much time it spent on this router, what happened. And by looking at those timestamps, you could perhaps then begin to diagnose where the problem was. Right now, all we get to see is the end viewpoint. Yeah, I sent the packet at this point in time, I received the packet at this point in time, assume everything is synchronized, and I can basically kind of from these cross-sectional views through the network, perhaps make some inference. So the goal of this project is the following. Could we create a debugger for the network? And the way we seek to create that debugger for the network is to begin to timestamp where my packet was at what point in time, and begin to have that fine level of insight into the packet transit behavior. Now, this problem is made hard because your packets, when they flow through the network nodes are very high speed. So it's not like things go into a software and sort of are being leisurely kind of scheduled and forwarded. It's all being done in a very fast fabrics which are part of the router. So the goal out here is that by making use of the hardware resources or resources that exist in these switches and routers, could we begin to timestamp things accurately enough, but let the application do it. So like, for example, if an application suspects something weird is going on, then it can ask for this information. It will obviously come at an extra cost, but now it's kind of like the equivalent of breakpoints or kind of observations, but now about the network as it is transiting through the. So what Fatima has been working with is there are Ethernet boards which have FPGAs on them. They're called net FPGAs, and through which you can basically begin to do stuff to packets as they are arriving or leaving. So you can kind of imagine mimicking a network router where now you have the ability to kind of program some network level behavior. And there's a close cousin technology which has emerged in recent years called software defined networks, whose goal is to let the characteristics of the network be defined in software. So this project deals with that. Chat with Fatima if the space kind of interests you. Okay, just a second. Okay, so this one relates to something I mentioned earlier, that I can begin to mess with the notion of time by delaying packets and all. The goal out here is, could I create secure network? network time which is secure against an adversary which is injecting delays. So it could be something on your compromised home gateway or a compromised network switch. Could I create a system which can detect someone messing with the notion of time, including potentially the OS which is missing? So in particular, this is motivated by a work out of Switzerland which appeared a few months earlier, uh, which provided a way for what is called as attacks during rollback. So let me describe what these guys had done. So these secure enclaves that I described, one of the things that they do is that if the system is powered off and on, then the state of the enclave is stored, and then later on, it is uh, uh, when the application starts running again, that saved state is brought back up again. And it turned out that an attack option opens up, which is the following. Let's say I'm an app running inside the enclave, and I'm checkpointing my state. So I checkpointed it at 10 a.m., I checkpointed at 11 a.m., I checkpointed at 12 noon, and so on and so forth. And then when I restart, then the OS restarts by providing me the latest checkpoint. But if the OS is compromised, it can give to me not the latest checkpoint, but a checkpoint which is older, and essentially thereby causing a rollback from happening. So what the group in Switzerland did was they provided a solution to combat these kind of attacks, this type of a timing attack. It's messing with your notion of time by creating a web of trust. So the idea is information about what was my latest checkpoint is maintained in a cryptographically secure manner by other agents running on other systems, other versions of my applications running elsewhere on the internet. So collectively, we kind of create this trust so that even if my OS is compromised, I can still know what the truth was. So in a sense, the model of the adversary out here is that not all the systems or not majority of the systems where I'm running would be compromised, so I can use that fact as a way to maintain a globally distributed, trustworthy time. So we want to sort of explore the same idea out here that by making use of the fact that I may have agents running at multiple nodes and an adversary which is causing delays cannot simultaneously attack all the systems or majority of the systems on the network, could I create a trustworthy notion of time? So again, talk to Fatima if you have an interest in this space. Let's see. Let's take a 5-minute break. It's a 3 p.m. thing. So let's start. I have another dozen or so projects to go before. Okay. And again, I think the best thing about these projects is talk to the mentors. Okay, so 5 minutes. Yeah, as of now, there's still 33 students in the class. Okay. But let me, I'll another attendance. Okay. That's okay. Let me.
I see my timesheet for October. Yeah, thank you. I need one thing to ask because right now I didn't enroll this class, but I do need this class because two reasons. One is my second graduate year.
You can petition and take another course.
Oh yeah, I tried to petition, but some of the other courses I already taken, and some of the
There are lots of courses.
yeah, I know. I tried I try before you. The second.
Unfortunately, I can't. So you just have to. There are any E course, any CS course you can take.
Yeah, I tried other course, but some other courses say this semester is lowest. So,
There are tons of E courses and tons of CS courses.
but I use this course for graduate. It's a circuit.
You don't. There is no requirement that you need this course.
And the second reason because I need a research related because I'm when
If you are pursuing a PhD,
yeah
are you?
yeah
Whose student are you?
Dr. Labor
Dr. Leha's student.
yeah
And so why do you need this specific course?
I my research spec is embedded system testing and validation so I do really need this class for research because if I enroll other using other part of the CS and E course that course is not related to my research so I just waste
No,
my
you can always pick up this material on your own. I mean, the
yeah
thing is, okay, you explained to me. I mean, but I did you fill out the web form?
I didn't do
Then yeah, so unfortunately, uh, you just have to.
yeah, that's the reason before I go to class, I try other similar class like machine learning, but that class is full and the course. So,
Just take any course. I mean, any E or CS course is fine.
but I do need this course. For
No, there is no such requirement. I mean, look, there are many students who are in the same boat.
yeah, but my research also need this course, and I also wait for 2 semesters. First semester I joined the course that you can wait for the educate year, and the second for last semester is the E202B. Some power.
Mhm.
I still
So,
not I still not enrolled
what all courses have you taken?
right now.
Yeah.
Other courses, uh, except your course. I take it. I
Have
already
you done
take
Professor Kaiser's?
guidance.
Uh-huh. Have you done Professor Bill Kaiser's course? 202C.
To see. No, that course is not available for this
Okay,
semester.
which year are you in?
The year 2006 4.
No. Which year are you in? Like, which? This is your first year, second year, third year?
Yes, second year.
Second year.
Yeah, so
We need to talk offline, but unfortunately, if you didn't fill out the web form, you are the lowest priority.
Yeah,
And
yeah,
there is
that's
no
really-
there is no requirement that this class is required for anything. It's not.
Yeah, that's the reason why I want to talk with you.
Yeah. So the thing is, I mean, but sort of, in any case, right now I have more students. than
Yeah,
can
I
so,
know you.
So at best, what will happen is that I'll give you the high priority, but I have to see what you are describing because I have to
Sure,
assess it
sure.
against everyone else.
Sure. Maybe I can email.
Yeah, you email me the set of courses you have taken.
Yeah.
I'll verify with Diana that you are a PhD status student.
Yeah, I also can get my professor letter to
No,
you.
I don't need his letter because I'll verify from Diana. So you send me your name and student ID, and I'll
Okay.
see what your status is. Okay?
Sure. And do you need my research work to embedded
Yeah, if
system?
there's something that you
Yeah,
have
yeah.
done, point
Yeah.
that to me. Okay.
Resume.
So I'll if those things
prove I'm
sure,
truly.
sure.
Otherwise,
In that
some
case, I'll give you the
people-
high priority. But right now,
Yeah.
obviously, unless
Yeah,
students drop out, I can't.
Yeah, maybe some people use this one, but actually not doing that one.
Okay.
So
Sure.
I'm really thank you very much.
What's your name, man?
We could
Huh?
WEIKUN.
WEIKUN. Vehicle.
Yeah.
Okay. Drop me an email and okay.
Yeah, this is the third time I tried to your
Okay.
class, but and I think this is last chance because next semester I won't graduate.
Okay.
Otherwise, it's
Send me your name and the student ID.
related or
Yeah. Okay.
very much. Thank you.
Asking, can I get a driver after this class? Because if I drop in on Wednesday, I'll have 1 day for homework. Yeah, I only have like a M4 driver.
Yeah. So as of now, yeah, I'll go through an attendance right now to see where I stand. But you're saying you're not enrolled in the class, right?
I am.
Oh, you are.
Yeah.
Okay. So what's the question then? I'm sorry.
Can I get the developer board for
Oh, the developer board. Yeah.
like,
Just come.
after this class?
Just right after the class. Yeah.
Right
Sure.
after the class.
Right after the
because
class.
if it's Wednesday, I don't.
Yeah. Absolutely.
Thanks.
Yeah.
Hello, Professor.
Hi.
We didn't enroll the course. Can we just follow your code and do the homework and the projects?
Sure. I mean, I'm not going to stop anymore.
And could you please grade our homework?
Anything which can be auto-graded, we will. Nothing which requires manual grading.
So the only chance that we can enter this class is where the enrollment rate is lower than 30.
Yeah, right now it's still at 33, so it hasn't, at least on
But
registrar.
if I don't officially enroll in this class, how can I take 202B?
You can take two. Well, firstly, 202B is not being offered this year at all, and 202C is independent, and 209A is independent. Okay. So next time 202B will be offered will be
Will there also be a
2019.
form sent out for 202B students to decide who can enter?
Hmm?
But will there also be a form
Yeah.
202B?
Mhm.
But what if we still can't
Are
enroll?
unable to get in? I guess I'll probably have to prioritize somehow. And one thing would be that if you have not taken any embedded system class, I'll give more priority.
Can we join your course and do the projects?
You know, it would be hard for me to grade and all. So, and I don't know why you want to make your own life miserable.
Because both of us really want to have a career in embedded systems, so it's
You're in your first year, second year. What are you?
of our first year.
Yeah, so just wait. I mean, most
Actually,
you were the
planning
least.
to.
You can feel free to follow on if you want to do one of the project. Sure, be my guest. Okay.
Thank you.
Sure. What are your names?
My name is Wei Qian.
Wei Qian?
Weiqian.
Okay.
I sent an email to you about my plans because
Okay.
I'm planning to graduate as early as possible, so it's pretty
Okay.
important for me to take every embedded system course.
Okay.
And also, I'm switching my advisor to Dr. Kaiser because I'm currently in his tutorial development team.
Okay.
And I'm also a mentor for E96C.
Mhm.
So I'm really planning to do something related to embedded systems.
Okay.
So I really want to join the course.
You in mind? And
Thank
what's your
you.
name?
Andy.
Andy.
Yeah.
Okay. And you're also Bill Kaiser student?
Yeah, we plan to join to
Okay.
make a one team.
Okay.
Thank you.
Cool.
Thank you.
So in regarding to the details about some topics, are we going to talk to the mentor?
Yeah. I think that's your best bet because I mean I have said what I need to say. In some cases I'm the mentor, in which case you talk to
Okay,
me.
okay, and also for the final assignment,
Mhm.
so when it's gonna be shown to us?
So when should we give the proposal of the project?
What do you mean by final assignment?
So I guess you're gonna decide which group gonna do which assignment, right?
No. I'll
We're
now.
just free to pick any topics.
You are
Oh yeah.
no, but you have to consult with me prior to your
Okay.
proposal because
So-
I will probably not let two teams do the same project.
Okay.
It'll have to be pretty
So
rare.
do we
Okay.
need to choose a preference for the projects?
Yeah,
Just
come
in
and talk with
case.
me. Whoever grabs the project first, grabs the project first.
Okay.
Okay.
Right.
Yeah. Okay, so let's restart. If any of you need the developer embed board, then you can come with me right after the class to collect. Okay, so just want to throw that out because otherwise, after today, the next opportunity would be on Wednesday, which might be a bit too late. Okay. The other thing is for these projects, if you are interested, again, unless I listed myself as the mentor, you should go and talk with the listed mentor. Generally speaking, I will let only one team do any given project, and therefore it's kind of on a first come first serve basis. What that means is I'll be putting up a web font for you to indicate your projects, but before that you need to come and talk with me and have my okay, because I will talk to you about your background and stuff like that. So you can't simply fill out that web form and say I pick up project number 17, and by the way the project numbers would be the page number. So there's no project 1. They start from project 2 because the title page is project 1. So come and talk with me. I think it's extremely important, and talk to the mentors. So talk to the mentors, make up your mind, and then kind of talk to me. Okay, so next one up, social interaction as a service. So this was kind of motivated by the following, that a lot of, and again kind of came out of some chit chat between me and my students. So a lot of stuff about ourselves or about people can be inferred from who they meet and what they meet, okay, objects and people, and kind of the temporal dynamics of it, right? I mean, for example, the place where I spend most time at perhaps is at night is perhaps my home. During day, okay, people I spend most times with are perhaps somehow related with me or some other sort of close relationship, and ditto for objects and things like that and all. And this, if you think about it, your phones obviously capture this information, right? I mean, it's location, encounters with people, and encounters with objects. Encounters with people could be through, I mean, in a more intrusive setting, it could be uh, uh, parsing your email, text messages, and stuff like that, but also sort of somewhat more easily with somewhat more privacy sensitive manner with things like Bluetooth IDs and things like that. And likewise for objects and all. So kind of the thought out here was the following, that could we make this kind of information available as a system service? So if you think about it right now, like your mobile OSs provide you a contact list, but the contact list is very static. It has people's name, it has phone numbers and stuff like that. What if it also had information about the dynamics of your interaction with them? And likewise, why should we limit the contact list to list of people? Why not just objects in general or places in general? So like this is a place which is popular. So essentially we kind of make our interaction with things pop up and have a directory maintained by your system, which you can kind of query, and which sort of queried at a population scale can lead to other kind of information. So the idea out here is that create a background service on Android phones which keeps track of information about your interaction with places, things, and people, and assembles them and then exposes them for other applications to query and all. Okay, so you'll have to think about what are the relevant temporal dynamics to capture. Certainly you can't simply just capture an event trace because it will soon blow up. So there's some relevant statistics that you would have to think about, make the case for why that they need to be captured, and then think about how to kind of expose them, and interesting things could be done and discovered from it. And again, this obviously also raises issues of privacy and all, so you'll also have to think about how to sort of have certain privacy control around this. So it could be some sort of a background service with an API with which other applications can query it, and meanwhile it is collecting data from sensors and all, as well as if the user so permits, from your social media slash communication apps also. Autograder domain specific language. So this goes into kind of the system we have running at the back end, where you upload a code, that code runs on a device under test, and then that device under test is subjected to some inputs, and then it also monitors the outputs, and then the instructor or homework designer specifies what those inputs to the device should be, and then it defines an expectation on what the output should be. So for example, in the current homework is a pulse width modulated thing. So you can imagine that we have specified something about how we are going to feed that 5-bit number that we provide you with the PWM ratio, and then your output waveform, and we have to specify what it should look like. Right now, the way we do it is literally we kind of essentially program that behavior. Okay, it's very low level stuff. What would be nice is that if we can define sort of a high level language so that an arbitrary new or a fairly arbitrary set of new homeworks can be defined. So you can think of a homework as nothing but an input specification and a sort of something stimulus and response. The tricky thing out here is that the response is not simply a value, but also has a time behavior. And also, generally speaking, we want to provide some slackness in that, right? For example, I may say the system has to generate, I don't know, let's say, for example, maybe the homework is the input is going to be a number and the output is going to be a square wave of certain frequency, and we want to provide some tolerance in that, in the sense that certain amount of error in the frequency is still acceptable. So we are going to, so how can we specify these things? So I guess the closest thing that we have out here is there's a CPS course at Berkeley where they've created something called a CPS grader. And what they use is something called temporal logic. So temporal logic is your standard logic, propositional or first order logic, but enhanced with the notion of time. And so what they do is they specify a set of constraints that the students' assignments ought to meet, and then they capture this thing and sort of verify against that. So that would be a starting point, and it may very well be that that would be the first thing to try out. The kind of things we are looking for a little bit more somewhat different. Our emphasis is less on interacting with physical things. So the kind of homework that Berkeley offers are things like a robot interacting with stuff in the environment, and ours are a little bit more about I/O behavior at the pin level, okay, both digital and analog. So in any case, what we are looking for is, in this project, is a domain-specific language where the instructor can specify what the homework is, and then your system has to essentially take this specification and compile it down to a generator for to the generation logic for our low-level language that we have, as well as take the output that we have captured and test it against what the instructor specified as acceptable things. This way of auto grading or kind of thing is something which is becoming quite fashionable in to cope with large number of students, and also in software it is mostly a matter of looking at values, but here you have to worry about timing behavior also. So that's the complexity. Okay. So this also relates to the autograder. So the challenge that we are dealing with out here is the following: that different homeworks that we give out, they often require an interaction that the board we have, let's say an embed, be surrounded by a particular wiring configuration. And currently the way we do it is that we wire it at the back end every time we release a homework. But that takes away from the general purposeness nature of this thing. Imagine that if this is something running as a cloud service, you would like the instructor to just specify, I want to monitor this pin and just give some of this thing, and might even involve some pin, one output pin feeding into some other part, those kind of things. So the thought out here is that maybe we can place an FPGA board next to it, and the wiring diagram is essentially a specification for this FPGA board, and then it configures the hardware appropriately. So for example, currently our homework had these specs like you have to produce read input on particular pin numbers, and you have to have output produce some certain pin numbers and all, and then we sort of wire it up to our instrumentation boards in our server. We want to kind of automate that process. So that's what this project is about. Underwater localization of animals. So the problem which we have been working on this one is the following, that we want to track both macro and micro movement behavior of sea animals like penguins. The thing is that these animals also spend a significant amount of time underwater. And GPS does not work underwater because radio waves penetrate only a little bit into water. So the idea that we have been doing is the following, that okay, so that's one point. The other thing is GPS itself is extremely power hungry. So even if it worked underwater, you probably wouldn't want GPS to be continuously on. So what the approach sort of some students in my group we have been working on is that we have a tag where we have inertial sensors, so accelerometer, gyroscope, magnetometer, depth sensor, and we have a GPS. And the theory is the following, that while it is underwater, we make use of these inertial sensors to keep track of relative location. And whenever the animal comes up to the water, then comes up to the surface of the water, then we at least know that it came to z equal to 0, depth equal to 0. And if it spends reasonable amount of time at the water level, then we can get a GPS lock and know the x and y also. And so now essentially what you have is a trajectory from the inertial sensor data, but once in a while I have additional information, either the z information or x, y, and z. And you could be smart about things like GPS could be activated when you are coming near the surface or at the surface, so you can save power there. The challenge which comes is that the IMU part is pretty tricky out here, because unlike, let's say, our phones and all, these animals kind of, while they swim with their body going through all sort of torsions and stuff like that, so the movement patterns are a lot trickier than the kind of things that you face when you have your phone sitting in your pocket, for example. So from a tracking perspective, the movement is sort of trickier, and one needs to go for more sophisticated algorithms, particularly because remember these sensors, the IMU sensors are pretty noisy, okay, even under kind of good circumstances. So this is more of a algorithmic / software implementation work, because we obviously don't have real penguins here at UCLA, but you can try to mimic their motion patterns and stuff like that by collecting the data, arbitrarily suppressing the GPS. We do work with scientists who are deploying them on penguins and whales and stuff like that, but sort of for the purposes of this project, you kind of mimic as if you are collecting data with in those kind of patterns, but really focus on the algorithm. And we have some data already with us. This one I kind of threw out, continuous blood pressure monitoring. So currently, as you know, like the home instruments for blood pressure monitoring are things where you kind of put cuff around your arm and then kind of fill in the air and then kind of measure the blood pressure. But blood pressure in patients can change very rapidly, so oftentimes in reaction to certain foods or stress or things like that. So in many cases, it's extremely useful to have continuous blood pressure monitoring. But that's a little bit tricky to do. So there's some approaches which have emerged. One approach with blood pressure has to do with looking at transit time. So as your kind of blood is pumped by the heart, you kind of measure what the heart is doing, and then you use PPG, pulse photoplethysmography, either at the finger or the wrist, to see when the wave arrived there and look at the transit time, and that relates to blood pressure. The way PPG works is the kind of stuff like if you have a smartwatch or Fitbit and all, they have these LEDs at the back which shine light and look at the bounce light, or if in hospitals you may have seen these finger cuffs. Okay, so they basically look at the light interacting with the blood and working with that. There are other examples of it also. People can look at your face, and every time the blood is pumped through your face, the slight changes in the complexion, and you kind of pick that up. There are also certain motions, you can pick them up. So there are a variety of ways that one can examine that waveform. So one work is time-based, but another one which has come out recently is the following, that the shape of the PPG waveform, in the sense that if you're sampling that waveform and have access to the analog waveform, then looking at its shape reveals something about blood pressure also. There are some papers around that. I cited one, and the idea out here would be to develop using embed and kind of a PPG cuff and see how well we can do in estimating things. And I think by looking at sort of better machine learning algorithms, I think one could do much better. So these kind of things have emerged relatively recently, but there's again lot of interest if we can do continuous measurement as opposed to requiring someone to kind of wear the cuff. Automated parsing of data sheets. So whenever people start designing complicated hardware, one of the first things you go around doing is to hunt for parts meeting with certain specifications and things like that. Now this information exists. Manufacturers do put out PDF files and stuff like that, but very little of this thing is available in a form which makes searching easy. Like I'm looking for a part with a certain characteristics, how do I go around kind of go around doing it? So the notion out here is the following, that technologies for parsing documents has advanced considerably. It partly goes under the umbrella of natural language parsing and things like that. It's used quite a bit in other domains. But electronic parts are kind of a more complicated beast. You're not simply looking at concepts in a newspaper article and all, but you're looking for very specific pieces of information. So the idea out here is that could we could we employ technologies like NLP? They typically basically nowadays a lot of them are using deep learning kind of things. There are entire kits there. Could we create a system which can parse PDF data sheets and for different category of components essentially create a searchable knowledge base which we can then sort of expose for people looking for various kind of parts. If I'm looking for a particular component with certain electrical characteristics, I should be able to search those. And in the same vein, parsing research papers. And one particular goal that we have in mind is sensor privacy. So what I mean by that is the following, that I have an application, I'm designing the privacy sort of a privacy firewall for a mobile operating system. An application comes to me and says, I need this sensor data. I want to be able to tell the user that if it is sharing this combination of sensor data with the application, then what all risks the user is taking. So imagine that on your phone, currently it says the application has asked for inertial sensor data or accelerometer data, do you permit? And most users don't really understand the application. Yes, no, but I showed that slide, I think last lecture, where there's a whole bunch of inferences that can be made. And the way we come up with that list is that there are conferences where people publish paper and they say, hey, lo and behold, from accelerometer, I can tell the gender of the person speaking nearby, those kind of things. Or the example I had, battery power, you can tell where you are, okay? So papers publish this kind of information. And it's kind of a constant struggle keeping track of it, right? I mean, someone shows some vulnerability, suddenly kind of sharing that data becomes a little bit more tricky. So what we want to create out here is kind of two components of it. One is a cloud service to which your device can consult and periodically kind of download a risk set, which is for different combination of sensors being sampled at specific rates, what are the inferences that a sophisticated adversary with the right machine learning tools can make from it. But the other part is how do we populate this database? So one is experts in the sense that people who have knowledge, but the other is automated parsing of papers. So there are certain conferences where these kind of papers emerge. And usually the abstract tells you a lot. So what if we were to just parse these abstracts and then extract what they are talking about in terms of possible privacy risk of certain type of sensor data and auto-populate the system. And the other source could be humans in the sense that you could imagine that someone enters this thing and gives a reference and then we go and kind of validate. But we are more interested in this automated thing that just keep track of every time papers come and they report some new privacy threat, the system automatically kind of updates along with kind of the necessary citation and all. So these two projects are both kind of, the previous one and this one are both seeking to employ advances in natural language processing to extract selected information from electronic data sheets in one case and research papers in another case. Yeah, this one, activity recognition from Wi-Fi packets. The idea out here is that someone snooping outside your home who is unable to look at the content of the Wi-Fi packets or other radio traffic from your home, but has access to the temporal behavior and the signal strength and these kind of characteristics, physical characteristics, and any public metadata which is there. What all can they infer about activities at your home? So there's some prior work in this space which has shown that by looking at these activity patterns, we can begin to talk about things like where are the sensors deployed, is there someone at home, things like that. There's a bunch of inferences you can begin to make by looking at, because these packets carry some ID, MAC ID or other sort of unique ID. So by examining them over time, you can begin to make a portrait of things happening inside the home without decrypting the payload because you don't have access to the key. So that's this one. Extracting information from house blueprints. So I guess this and this kind of go hand in hand, which is nowadays a lot of information about homes is available from public sources. You go to Zillow, you learn a lot about it, right? How many bedrooms, how many bathrooms, stuff like that. You go to Google Earth, you begin to get some notion of the footprint and all. So the notion out here is by looking at these public sources, what kind of information we can begin to construct, and ideally perhaps even combine it with other live information that you are getting, but at the very least could we begin to articulate what kind of characteristics that home may have. Even things like, for example, do you have a very old model AC unit, things like that. So depending upon what sort of the image is showing. Let's see. Okay, so this project is using reinforcement learning to filter desired smartphone notifications. So the problem which is dealing with out here is the following. If you are anything like me, every time you open the phone, you would see kind of a whole bunch of notifications. And sometimes they are duplicative, sometimes they're annoying, and applications kind of keep pushing them at us because the way operating systems provide notification capabilities are very simplistic. It's either based upon time or like whenever the event happens. What if the system could learn what notifications I like or act upon or don't like, or when do I like to receive notification? Maybe certain things I don't want to receive, like for example when I'm giving this lecture and things like that. So could we make the delivery of notification adapt to a specific individual? So one of the ways agents or artificial agents can learn about their environment, or in this case the user, is a technique called reinforcement learning. And the idea in reinforcement learning is that the agent does some action, and then based upon the feedback from the environment, it adapts its behavior. So for example, in the notification example, it could be, did I act upon it? Like for example, I have an app on my phone which kind of keeps reminding me that it's time to get up and walk a little bit, but most of the time I ignore it. So that's a feedback. I have another app which reminds me to drink water, and again, most of the time I ignore it, but sometimes I do. What are the circumstances under which I do? So these kind of things, like over time, can the system, instead of blindly still insisting on pushing things at the user, can it begin to learn about when is the user interruptible, when is the user more likely to take action on it? You can imagine other situations under which it's useful. These notifications may be a commercial service which is being offered to, just like ads are thrown on websites, these are notifications thrown at users depending on their context and all. And again, someone paying money would like to get good return on investment. So when is the user more likely to be responsive to this thing? So the notion out here is that could I design the notification system so that it adapts to the particular user, and the way it adapts is by maintaining a model, creating a model of the user, and creating these feedback mechanisms. Did the user react to it? Did it dismiss it? Did it actually do the task which was asked for? So my student Bo is the one kind of on this, but there is some work in the space, particularly from Japan, where they have tried to look at things like when is someone interruptible. For example, one concept which has emerged is the claim, may or may not be true, that we are more liable to act upon something if it happens when we are switching from one task to another. Okay, that is the right time to interrupt. So like, for example, maybe the right time for you to interrupt me is when you see me leaving the lecture and before I get busy with my next meeting, for example. Okay, so that transition time is the one which is the best one to capture. So those kind of ideas are floating around, but none of them have approached them from this perspective of reinforcement learning, which is a general technique that has emerged in AI literature as something as to how you learn about your operating environment. In this case, the operating environment happens to be the human user. So can the phone learn about me and then adapt things? Or other examples could be reminder to take medicine, pushing a reminder to me when I'm at work while my medicine at home is kind of pointless, or so I'm probably not going to act upon it. On the other hand, maybe some people carry their medication with them, and therefore in their case it's okay. So everyone is different, and reinforcement learning can provide that framework. Okay, virtual sensors. So this concept of virtual sensors has been around in some shape and form quite a bit, and what it relates to is the following: that normally when we think of sensors, we think of some specific hardware device, but the reality is far from it, in the sense that if you think about the way sensors work, we oftentimes process information from a sensor and then expose a derived information as a sensor data stream. So like, for example, on Android, you also have things like linear acceleration and things like that, which are actually computed. There is no sensor for it. And likewise, oftentimes we fuse information from multiple places, put it into some signal processing or machine learning kind of algorithm, and then take the output time series or output series of events, and that's what we expose as a sensor. So sensors don't need to be simply low-level output of a hardware, but oftentimes they are processed and fused versions which are now kind of software. And this thing, I guess the important role that software is playing in processing hardware information is something which is really catching on. So I'll give you a few other examples. If you look at what's happening to cameras now, so at least when I was growing up, a lens that I would buy for my DSLR was just a piece of optics. And then sometime in 90s and early 2000s, the lenses became a little bit smarter. They began to have electric interfaces so that they could be controlled, their focus and aperture and all could be changed in software. And now if you look at lenses, they're even more so. I mean, in the sense that the raw optical output that we get is then significantly processed to give me the total image. And so if you look at like the phones which are coming out now, right? I mean, Google's Pixel 2 from a few days ago. These things are really optical plus computational photography. And I think the same thing is true generally for sensing. They are hardware plus software working together to give you kind of some sort of a sensory output. So the notion out here is, could I create a general framework out here? So there is masses of data out there, okay? But it's oftentimes low-level, unprocessed data from every government agency pushes out data nowadays, scattered all over the web and all. Could we create a software framework where people can define virtual sensors, which are nothing but snippets of machine learning algorithms, taking data from sources and processing them, and then republishing this derived time series as a value-added a different kind of inference that is being done from already available data. So we want to create a virtual sensing framework, and it turns out that there are already good software frameworks that exist for us to process sensor data at scale using cloud services, systems like Kafka and Hadoop and Spark and all, which address different pieces of it. And notion out here would be to sort of create this thing where people can publish and instantiate new virtual sensing systems. Okay. What this one is looking at and is the following, that if you look at sensors at your home, if you have them, a lot of homes do now, they send out traffic which goes to some sort of a cloud service. So like, for example, at home I have Nest cameras, and I have their smoke system, and they have motion sensors in them and all that traffic is going to Google. Same thing, a whole bunch of other devices, your security system and kind of wearable sensors and stuff like that. There are one type of privacy attack, which is someone examines the content of those packets, and that's easily taken care of because at least any reasonably well-designed modern system will probably use end-to-end cryptography. So you're going to use SSL tunnels and all, so no one can examine that data. But they can still examine the temporal characteristics of that data. So let's imagine I have a motion sensor. Its traffic may be encrypted, but if it sends the burst of activity when someone enters or leaves, then that's a giveaway. So there's a lot of information being leaked by a system just by the patterns of traffic that are being done. And also changes in patterns of those traffic can also be revealing. Like, for example, if the data from this sensor was always going to machine A, and then suddenly one fine day you realize that, hey, it is now going to machine B, what would you suspect? Probably some malware might have taken over that, right? So traffic can reveal a lot, and the changes in patterns of traffic can reveal a lot, okay? Also, I had mentioned last time around that the way our internet system works is we also make DNS queries. We look for a host, we query the IP address of a host name. So prior to a traffic, if a DNS query is being made, that says something about where is the data going. If prior to your sensor data, if it comes out that a DNS query is being made to whatever xyz.russia, then you should raise eyebrows. Okay, what's happening? So, so traffic pattern and without even breaking the crypto can tell a lot. So in this case, the goal is that could we create a home gateway, because all the traffic goes through the home gateway, which can examine these kind of traffic and then look at what kind of unintended privacy leaks might be happening and then warn the user. Okay, so for example, this gateway, by looking at the traffic pattern, can, if it detects something suspicious, then it can contact the user through, let's say, some smartphone app or something and say, this sensor is doing that. Is that okay? So kind of a smarter firewall, which is kind of looking out for these anomalies and all, based not on content, but really by analyzing the pattern of the traffic. Okay, I think Bo has been fond of laughter detection for a long time, so hopefully one of you will make him happy and make him laugh. But this one is about, can we detect mood, and can we therefore detect that the person is laughing. Okay, so it's a simple project. Okay, Smart Chef. Okay, you can read it. I'm not much of a foodie, so okay. I have a few other projects which I've been thinking about. I'm going to put those up also. Also, by no means is this list supposed to be the one out of which you should be picking projects. You can think of them as the kind of projects, perhaps the space of projects. But I'm obviously open to any other ideas that you guys might have. And so best thing is to come and talk with me or talk with my students to bounce around ideas. Oftentimes, as you start discussing one of these projects, you might realize that some variant of it makes more sense, and that's perfectly fine too. Questions? Okay, so I'll hold. I have to look at my schedule tomorrow, but I'll send things out. But I'll probably hold some office hour tomorrow, but certainly on Wednesday evening, additional ones so that you guys can come and talk with me. Okay. You should start talking with me. Okay, the deadline for submitting that proposal is 18th, I think. That's what I had given. But you should start talking with me now. Okay, I mean 18th is when you're submitting, you should have discussed with me and decided this is my team. Okay. Any other questions? Okay, I still need to get a handle on how many students have dropped out of the course and not. So I'm going to send another email polling. Please do fill out, because there are some students still waiting to get in for a variety of reasons. The registrar office still shows 33, but let me see how many people are here. 1, 2, 3, 6, 12, 19, 25, 30, 32, 36, 38. So I have 38 students still in the class. How many of you are waiting for a PTE number? Okay, so 1, 2, 3, 4, 5. Okay, so I have all the 33 people in attendance. Okay. Okay, thanks. So I don't think I need to do the attendance. Okay, so if any of you do decide to drop out, please do let me know so that I can keep track. Okay, so if any of you need the hardware, just come along. Yeah.